In this video, I'm going to show you how to do some calculations considering the significant digits. If you haven't already seen a video on understanding significant digits, you should watch that first. And now we'll do some calculations. So two different rules. We'll do an example of each. For multiplying and dividing, the sig figs in the answer should match the lowest number of sig figs from the question. In other words, count the sig figs. Okay, so if I've got, say, 3.25, let's say, meters, and I'm multiplying that by 1.2 meters, whatever I get from my answer, the sig figs should match the lowest number from the question. So if that's 3 sig figs and that's 2, my answer should be rounded to 2 sig figs. Okay, that's pretty straightforward as long as you are able to count the sig figs. For addition and subtraction, it's a little different. You need to round the answer to the least precise place value from the question. And that's a little bit wordy, so we'll do some examples and it will make sense. But the gist of it is you look at the place values of the numbers that you're adding or subtracting. You're not counting the sig figs. So let's do a multiplying and dividing first. So this is maybe a question you might see in physics and science 10. So distance and time, you're going to calculate speed. Okay, now you know speed is distance divided by time. So that would be 20.00 meters divided by 2.7 seconds. Okay, and most people can do that okay. What we need to be able to do though is consider the sig figs. These zeros are after the decimal, so they count. So that's 4 sig figs. This is 2 sig figs. So what are we going to round our answer to? 2 sig figs. So when you punch this in your calculator, you're going to get some long number, something like this. That is the speed in meters per second. Don't forget units. Now instead of asking your teacher, what do you want us to round the answer to? Let's use our new rules here. We need to round it to 2 sig figs because in the question we only had 2 sig figs with a 2.7. So rounded to 2 sig figs, this becomes 7.4 meters per second. And if you just think about it logically, it makes more sense to say that than this big long number. We just cannot be that precise given the fact that one of the values in the question only went to 1/10 of a second. So let's look at adding and subtracting. Here we are considering place values instead of just counting sig figs. It's helpful to write these vertically. Now we're just adding these numbers up, which everybody can do. Just making sure all the place values are aligned. And put it all in their calculator. Probably don't need a calculator for this one. And you get 218.44. Okay, but that's not the right answer. We cannot be this precise because this 22, this device that measured this, is only capable of measuring to the ones column. In other words, the actual, whatever, this is milliliters, okay, so let's say the actual volume here, it could be 22.4 actually, but our device could only record it as 22, or it could be 21.6. Our device can only measure it as 22. So because there's more of a range, a possible range associated with that 22, it doesn't make sense to be so precise with our answer. So the best way to do this is to find the place value of the least significant digit, the ones column, draw a line after the ones column, and we're going to round to the ones. So this is just 218. Okay, milliliters. That would be the correct answer for this question. And just to kind of take it one step further, it might seem a little silly, but let's just say that this was 20 milliliters instead of 22. Okay, and we do the same process, except now we write a 20 there instead of 22. And so now we get 216.44 as our answer. What is the place value of the last significant digit here? This is in the tens column now. Remember, this 0 is not significant. So in this case, we would have to round to the tens column, which makes this 220 milliliters.